So let's take a look at this question over here. So in the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? Well, let's just write out all the information that we know. So x plus y is equal to u plus w, and we know that u and y are vertical angles, so u equals y, and t and x are vertical angles, so t equals x, and w and z are vertical angles, so w equals z. So let's just see which of these we could prove to be correct. Let's take a look at one. X equals z. So let's just take this equation and see what we could do with it. So x plus y equals u plus w. Well, here we know that z equals w, so we could just replace w with z and get x plus y equals u plus z. And then we know that u and y are equal, so we could just replace both with y, so x plus y is equal to z, equal to z plus y. And here it says must be true. So does x have to equal z for this equation to be true? Yes, it's pretty obvious to see that x has to equal z, because if x did not equal z, then well, because both of these y's will cancel out, we know that if x did not equal z, then this equality would not be true. So x has to equal z, or else something is wrong. So now we know 1 is correct, so let's take a look at 2. So we could just do the exact same thing. Y equals w, and x plus y is equal to u plus w. So first off, we just want to isolate y and w, and we know that x is equal to w because x is equal to z, and z is equal to w, therefore x has to equal w. So we could just do this, w plus y is equal to u plus w. So now we could also replace the u with a y, so we get w plus y equals w plus y. So in this instance, does y have to equal w for this equation to be correct? Well, it's pretty easy to see no, y does not have to equal w. W could be 30 degrees and y could be 40, and this equation would be correct. Y could be 30 and w could be 30 and it would still be correct. So y could equal w, but it does not have to equal w like this here suggests. So 2 is not correct. So let's take a look at 3. So does z have to equal t? Well, let's just look. So, well, t is equal to x, and let's see where we could go here. Well, x is equal to z. So if x equals z and x also equals t, then that must mean that z is equal to t, because, well, they're both equal to x. So 3 has to be true based off the information that we already know has to be true as well, meaning that 1 and 3 are correct, so the answer is B. Thank you for watching.